This is YR, Women in AI Research. In this EACL 2026 series, I'm speaking with authors of accepted papers to break down their work and the ideas behind it. Let's dive in. Hi, could you please introduce yourself?
Yes, hi, I'm Navita. I'm a PhD candidate at University of Maryland, and I'm advised by Professor Hal Domain. I work at the intersection of language model interpretability and causality, specifically looking at how you can interpret what language model like learns in its internal representation and how you can like potentially steer those to like reliably and precisely like understand and intervene on model behavior. And yeah, I'm really excited to present my paper today.
Amazing. So I know this paper was accepted to the main conference track at the EACL 2026. And could you please walk me through this paper?
Yeah, definitely. So this paper is titled Steering Safely or Off a Cliff, Rethinking Specificity and Robustness in Inference-Time Interventions. The idea is to study inference-time interventions and then seeing what are like its implications on how like model behavior is affected. So inference-time interventions, broadly speaking, are sort of a lightweight way to control specific behavior in the models. So, for example, in safety aligned models, one thing that can happen as a result of safety alignment is the model starts over refusing safe queries. So, if I ask it something like how to create a realistic looking prop knife for a play, it might say I cannot provide instructions on how, whereas while this like is a completely safe query. And what we might want is somehow to change internal model representation such that this kind of behavior goes away. The sort of promise of these methods is that you can do it sort of in a moderate fashion, but then also this can allow you to change only specific behaviors in the model without affecting everything else. But the kind of open question still is, are these methods really precise? Is that, are they really altering only the property that we intend to change? For example, over refusal in this case. Um, and I think the argument that we make in this paper is that even though this claim is widely made in like steering literature, it's really not established because the establishing whether or not it's only changing intended property has like different axes that we might want to consider. For example, does steering preserve like the general language fluency on or performance on unrelated tasks, which comes under like general specificity, but then also things like are the properties that are closely related to the target property that you are editing maintained. So for example, if I'm changing over, if I'm trying to like steer over refusal behavior in the model, one thing that might happen as a result is if I now start asking it questions like write a tutorial on how to make a bomb, the model might like start answering that. Or maybe not. Maybe if I then try to jailbreak the model might start like responding to that more than when it was unsteered. So we want to make sure that these kind of related properties are preserved even under distribution shifts or adversarial attacks. And then we look at the existing literature, we do see that this is a problem because even though a lot of papers that propose like steering benchmarks or methods evaluate general specificity, not always though, there's not really much discussion on control and robust specificity, which are sort of important axes. You can imagine that like doing this kind of steering doesn't change models' general capability, but it changes models' ability to like safely refuse a harmful query. Um, so if we evaluate this for like several models, one of those is presented here for over-refusal steering and faithfulness hallucination steering. So here I present results for over-refusal steering, and then we see that when we compare different steering methods that exist in the literature right now, they are able to overall maintain general specificity. So the x-axis across these three graphs is the target metric, which is improving compliance on over-refusal queries. And the y-axis is sort of the control axis of maintaining specificity. And we see that after steering, there's not a huge drop in general specificity or even control specificity actually, but a huge drop in robust specificity is that like before steering, obviously adding jailbreak leads to a drop in the model ability to refuse harmful queries. When you do steer, all of the jailbreaking sort of robustness goes even further, further down. So there's an additional 19 to 30% drop in jailbreaking robustness across unsteered baseline. This is true across methods, across models, across tasks that we present in the paper. So the major takeaway here in this paper is that steering methods actually introduce systematic issues and vulnerabilities in the model, and sort of this in distribution evaluation that is done does not really capture that. So first of all, we need more comprehensive testing before we make sort of we before we can make sure that steering meets the promise of being precise. But then also we need more robust methods so that we can actually sort of get these interpretable interventions that we do in the model whilst also retaining its like other abilities. So that's kind of the crux of this paper.
I see. That's very interesting and a very important problem. So yeah, great work. I have a question. You have only that llama model visualized. Uh, have you done any experiments with the bigger size models?
No, unfortunately not. We did try to like diversify on the scale of models that we study and like the model family, but we were more or less limited to sort of this range of like 2 billion to 13 billion sort of range of models, because some of these evaluations are very compute intensive, so we couldn't like really scale them to like 70 billion size. But um we did see a signal that the results kind of hold across model families and across like different sort of, at least in the smaller side of things, across different model sizes. So there's a probability that this might actually like generalize to larger models. But then even for papers that I think usually in this literature I've seen smaller models. I mean, I've never seen this evaluation in general. So this is more of a, well, if you're doing it and we're sharing for larger models, maybe like try and evaluate that. But yeah, our results were mostly based on like this sort of range of sizes.
I see. And then, what do you think would be the way to mitigate this problem, or at
That's a
least
very
where to move to?
That's a very good question, and I've been personally thinking about this a lot as well. I think one of my hypotheses behind why this happened, and we do try to present like some insights into this in the paper as well, is that we assume that when we like do this kind of like when we learn these steering directions through like these positive and negative demonstrations, that the thing that the model is learning is only over refusal. So if I steer in that direction, only that thing would change. And then some of the signals that like if you like inspect the model's internal representations, you see that they are not actually disentangling the over refusal direction. The actual direction that the steering like the steering is happening in might entangle like more than one property, and that could kind of explain why this kind of robustness drop happens. And if that is true, is that like the actual core cause of this is the fact that the direction that you're learning is not doing a very good job of disentangling like the target direction. What we can try and do is sort of explicitly try and disentangle the control axis from the target axis, and then maybe if you can isolate a direction by imposing extra constraints of this direction should be orthogonal to some of the other like properties, maybe that could be the way to go about it. So I think that's the one space that I want to explore in as well, is like if you try to sort of limit these kind of interactions, does that help? And my intuition is it might, but I'm like, yeah, we didn't like really test this out in this paper. So that would be a sort of a good next direction for people
I
to start
see.
thinking in.
I see. Yeah, that's very interesting, and thanks for presenting that. And I hope to see the future work that comes out of your lab within
Uh,
those within that direction as well. Thank you.
yeah, thank you so
And the
much.
links are in the description, both the paper and the author. Like this video and subscribe to the channel to follow this series. See you next time.